Welcome to the congruent section of the solving with similar and congruent triangles. So here we're going to be solving with some congruent triangles, and we're going to specifically be using corresponding parts of congruent figures. Anytime, or corresponding parts of congruent triangles, CPCTC. Anytime we know that, or prove that two triangles are congruent, we know that all the corresponding parts are congruent, okay? Even the parts that we weren't given. Okay? So here we're not given measurements for angle D and angle C and angle EBD, but we know they has to be congruent to the corresponding parts because our triangles are congruent. Okay? All right, so we want to find x here, but we don't know what angle D is. We can't just set them equal to one another. But what if we could find another angle in the triangle? Maybe then we could figure out what x is. Well, using CPCTC, angle C has to be congruent to angle E. And since angle E is 81 degrees, angle C is also 81 degrees. Okay? So let's mark that in the triangle there. Right? But now using triangle sum theorem, we can actually find our missing angle. Right? So angle A plus angle C plus angle B have to add to 180 degrees. That's the number of degrees of a triangle. We're looking for angle A. We know that angle C is 81 degrees. We know that angle B is 51 degrees. If we add those together, angle A plus 132 is equal to 180. Subtract 132 from both sides, and angle A is equal to 48 degrees. So now that we know what angle A is, we can easily solve for x. Right? So, because angle A, we're told, is equal to x plus 5. Well, since angle A is 48 degrees, that means x is 43. Okay? So here we've used a couple properties. We've used CPCTC, matching up our corresponding parts, and we've also used triangle sum theorem. Okay? All right, let's look at one more question. And this one is in your notes. Make sure you take notes, all right? Write this important information down. And of course, you can always pause the tape. You don't even have to wait for me. While you're pausing the tape, let's go to the next question. The next question we have here is we're going to use the side-side-side congruence postulate to show that triangle ABC is congruent to triangle FGH. All right, so this was something that we looked at when we were working with congruent triangles. And this is also something we can look at for using similar and congruent triangles to solve problems. Here we're going to show, using the distance formula, that side-side-side applies here. All right, so for side-side-side to apply, it would mean that, using my letters here, AB would have to be congruent to FH. And I'm going to put a question mark because we haven't proved it yet, that BC would have to be congruent to GH. And that AC would have to be congruent to FH. I think I'm losing my voice here. All right, so I'll try not to clear my throat too many times into the microphone. All right, so let's we're going to use the distance formula, and we can also just subtract the values for our horizontal and our vertical lines. All right, so let's just go in order. We'll find AB. All right, so notice AB here is just a vertical line. There's no change in the x, right? -7, -7. Only the y changes. So that means that the length of AB is just the absolute value of the difference in the points. And I say points, I mean the y coordinates, because it's a vertical line. Right? So I'm just going to put vertical line. So if it's a vertical line, the length is the difference of the y values. And its distance has got to be positive, so we'll take the absolute value. So just in case I change the ordering and I get a negative number, we know it has to be positive. All right, so AB is equal to the absolute value of 5 minus 0, and that's just going to be 5. Just put that there. Okay, so AB equals 5. Let's do the same thing for FH. And there we go. FH is did I write them down wrong? Let me see. AB. Oh, I put down FG or FH. I do not know why I put down FH. FG. Sorry, FG. Just when I was, scanning back and forth, I just copied the wrong letter down. All right, so FG. I feel a bit better about that. This time we have a horizontal line. So for a horizontal line, the length is just going to be the absolute value of the difference of the x values, x coordinates. All right, so we're just looking at x here, 1 and 6. So FG is going to be the absolute value. See, we put the absolute value in here because it doesn't matter which way I subtract. 1 minus 6. See, if I do that, I get negative 5, but the absolute value of negative 5 is just 5. So my length there is 5 as well. So now we can get rid of the question mark there, because it's no question. AB is definitely congruent to FG. They are both 5. Let's do the same thing with BC and GH. All right, so now we're going to have to use the distance formula. All right, so BC, we take the difference in the x coordinates. So we have negative 7 minus a negative 4, all squared, plus the difference in the y coordinates. So I started with B, so I have to continue with B. So 0 minus 5 squared. All right, so that's going to give us, that's going to be negative 7 plus 4. So that's going to be negative 3 squared plus negative 5 squared, which is 9 plus 25, or the square root of 34. All right, so that doesn't simplify. So BC here is the square root of 34. Let's find the length of GH. And I'm trying to think where I'm going to do that. I guess I'll start with smaller. I'll do it right over here. All right, so FG or GH is equal to difference in the x coordinates, 1 minus 6 squared, plus difference in the y coordinates, 2 minus 5 squared. And that's going to give us negative 5 squared plus negative 3 squared, which is 25 plus 9, which is the the square root of 34. So those two are the same. There we go. I'm not going to even try to write it on the label on the thing there, but I'll just box it. It's so close to the triangle. I'm not going to write it on the triangle. All right, so GH is equal to square root of 34. So now, no question there. Those two are congruent to one another. And now the last one is AC and FH. So AC, we'll just take the difference in the x coordinates because it's a horizontal line. So I've got negative 7 minus a negative 4. So that's the same as negative 7 plus 4, which is negative 3 or 3. And then let's do the same thing. You can hardly see it there. FH is that vertical line lying on its side. And our distance there, oh, I should have written in, this was AC. And FH let's put it right here. FH is just the difference in the y coordinates because it's a vertical line. So that's just the difference between 5 and 2, which is 3. So that is congruent as well. Okay? So using the distance formula here and subtracting our values, we've shown that our two triangles are congruent. Okay? So since AB equals the square root of 34. No, that one is equal to, that was AC equals 5. And FG equals 5. AB is congruent to FG. Looks like F6. Since BC equals the square root of 34 and GH equals the square root of 34, BC is congruent to GH, and since AC equals 3 and FH equals 3, AC is congruent to FH using side, 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 triangle. Actually, I'm going to change my sentence just slightly. Therefore, triangle ABC is congruent to triangle FGH, or F6H, as it looks like when I'm writing it, using side, side, side triangle congruence postulate. So we didn't just say they were congruent, we proved they were congruent. And we have now finished the congruence section of solving problems with similarity and congruence. Okay? So I hope you didn't find this to be too difficult of a problem. And if you have any questions, as always, just ask in class. Have a great day.